I welcome everyone to this video. I am Mr. Ish. Thank you for joining me. We're looking over here at a sum of a series. I have here from n equals 0 up to infinity what you see the formula, the rule, minus 1 to the power of n times 1 over 2 to the power of n. What is the sum of that series? As you were to include all the terms going up to infinity, you would add them up. Before we look at this question here on the top, look here at this one. N equals 0 up to infinity. I just have 1 over 2 to the power of n. When you are looking at this, you know you have a geometric series because you have a common ratio which will be the same. As you start putting values from 0 up to infinity, how does your series develop? You'll have 1 over 2 to the power 0 plus 1 over 2 to the power 1 plus 1 over 2 square plus 1 over 2 cube, and you'd go on and on. You're looking here at a 1 plus 1 over 2 plus 1 over 4 plus 1 over 8 and on. What's your common ratio? Your common ratio here would be 1 over 2. And why would it be? Pick one term and a term before and do their ratio. 1 over 8 divided by 1 over 4 will be 1 over 2. Another way you can do it is just when you know you're dealing with a geometric series, what you see right over here is your ratio. And why would that be the case? I'll show you. If I'm looking here at a geometric series which looks like 1 over 8 to the power of n, I know here my ratio, my common ratio will be just 1 over 8. You just don't look at that. What you're looking at is this. I'm looking at a 1 over 2 and that's my common ratio. And you can show that to be the case because if you were to do something like this and I'm telling you the common ratio is exactly what you see absent the exponent, that right there is the ratio. Think about it. You're looking here at a term and you're dividing it by a term before it. 1 over 8 to the power of n divided by 1 over 8 to the power of n minus 1, a term divided by the term before. You would have over here a to the power of n minus 1 divided by a to the power of n. If you do your laws of exponents, you bring it in. On the top, you have common bases. What you're really looking at is a to the power of n minus 1 times a to the power of minus n. Laws of exponents. When you have common bases, the exponents add. You'll have a to the n minus 1 minus n. When you take this to completion, you're looking at a to the minus 1, which is 1 over a, which is exactly what I told you. Your common ratio all along was 1 over a. When you have a geometric series, your common ratio is exactly what you're seeing in your rule, absent that exponent. Here my common ratio is 1 over 2. Remember, we're talking about this momentarily, then we'll come to this question on the top. I know over here my ratio, common ratio is 1 over 2. And when you know that your common ratio is less than 1, then you know your series is convergent. What does convergent mean? If you were to do a sum of the series from 0th term or even from the 1th term all the way up to infinity, all of these would equal into a finite value. Hence it's called convergence. If you were to add all the terms, you'd have a finite value. Your end result would not be an infinity, it would be a finite, reasonable value. When your common ratio is less than 1, it's convergent. I know my common ratio is 1 over 2. And in that case, your formula becomes this. The sum of the series is equal to a1, your first term divided by 1 minus r, 1 minus the common ratio. I've already understood that we're looking here at a convergent series because my common ratio is less than 1. And you can even view that rule as is. Your common ratio in absolute value less than 1. Sometimes this is a negative value, so you can make it into positive. It's less than 1, it still applies. What is my common ratio? It's 1 over 2. What's my first term? If you put 0 over here, my first term is a 1. 1 over 1 minus 1 over 2. My sum of the series will be 1 over 1 over 2, which will be equal to 2. If you were to do the sum of the series here, your total of all the items in your sequence from 0 up to infinity would equal to 2, and it would be a correct answer. So this right here represents the easier version of what you're seeing on the top. What's the difference between this and the one on the top? As you start putting in your values for n equals 0 up to infinity, you have an alternating positive and negative develop. If I'm putting n equals 0, I have minus 1 to the power of a 0 divided by 1 over 2 to the power of 0. My next term is minus 1 to the power of 1 divided by 1 over 2 to the power of 1. The next term here will be minus 1 square divided by 1 over 2 square. The next term will be minus 1 cube divided by 1 over 2 cube, and you would take this on and on. And this will very likely be a negative term because you have an alternation here. But look, you solve it out. Minus 1 exponent 0 is a 1, and you have here a 1. Here you have a minus 1 over 2. Here you'll have a plus 1 over 4. Here you'll have a minus 1 over 8. Then you'll have a plus 1 over 16. If you're looking here at this rule, this is how your series is developing, like you see over here. If you were looking at the rule previously, the second question which I already did at the very beginning, you're looking at 1 plus 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16. where all your terms were positive. In this case, your sum of the series equal to 2. Now when you're interspersing the terms with a negative, then you know the sum of the series going up to infinity must be less than 2 because you got negative terms in it. But what exactly would that value be? Utilize the same format I've shown you and let's proceed with that. What's my common ratio over here? I'm looking here at a 1 over 2. Remember I told you the rule, when you have 1 over a to the n for geometric series, your common ratio is just equal to 1 over a. But here I have a minus 1. So I can say my common ratio is a minus 1 over a. That's what it'd be. If you don't accept it, take any two terms. You have over here a 1, then you have a minus 1 over 2, then you have a 1 over 4, then you have a minus 1 over 8. Take any two terms. I have a minus 1 over 8 divided by 1 over 4. Any two terms such that you have a next term divided by the preceding term, and you will have here equal to a minus 1 over 2, which is what I will anticipate. My common ratio here will be minus 1 over 2. As you see, minus 1 over a, it will be a minus 1 over 2, because here I know a is equal to 2. We have that figured out. Now think about the rule of convergence. A series is convergent if the absolute value of that common ratio is less than 1. Our minus 1 over 2 absolute value is indeed less than 1, and it's convergent, which means my sum of series will be equal to what? It will be equal to the first term divided by 1 minus common ratio. And let's bring it in. Now your common ratio will not go through an absolute value. You keep your common ratio as is. Your common ratio is equal to minus 1 over 2. You run that through. What's your first term? Your first term is going to be this right here. And what is that? It's equal to a 1. Minus 1 to the power 0 is a 1 times 1. It's a 1. Bring the items in. Your sum of this infinite series, if you take all the sequence of items and you add them up, you have positive minus, what will it be equal to? It's 1 over 1 minus 1 over 2. And you have 1 over 1 plus 1 over 2, which is 1 over 3 over 2. And you take this to completion, you have 2 over 3. The very first example I showed you at the very beginning, at the bottom, was your sum of the series was equal to a 2. Here you're seeing a sum of series is equal to 2 or 3, and it should be correct. Only difference being is we threw in this, and it made all the difference. But that sum of series 2 or 3 should be good. It's a convergent value. And that's it for this video. Thank you for watching.